An artist's impression of the interstellar asteroid Oumuamua ESOM, so nobody saw it coming. The rocky object showed up in telescope images the night of October 19. The Pan-STARRS 1 telescope, from its perch atop a Hawaiian volcano, photographed it during its nightly search for near-Earth objects, like comets and asteroids. Rob Warwick, a postdoctoral researcher at the University of Hawaii Institute for Astronomy, was the first to lay eyes on it as he sorted through the telescope's latest haul. The object was moving rapidly across the night sky. Warwick thought it was probably a typical asteroid, drifting along in the sun's orbit. It was only when I went back and found it in the data from the night before that it became obvious it was something else, he said. He'd never expected to find something like this. Warwick and his colleagues scrambled to secure more telescope time to study this mysterious, fast-moving object. They called in reinforcements in the astronomy community. Initial observations suggested the space rock was a comet. When new data showed the object lacked some important properties of comets, they decided it did in fact have to be an asteroid. But it wasn't acting like any asteroid they'd ever seen. When astronomers examined and measured the object's movements, they were stunned. The object didn't originate in our solar system. It had come from somewhere else, and had traveled through interstellar space for who knows how long to get here. Astronomers announced the discovery of the object October 26, calling it A2017U1. The University of Hawaii team eventually gave it a permanent name of Hawaiian origin, Oumuamua, a messenger from afar arriving first. After weeks of follow-up observations, they have released more information about the finding in a new paper published Monday in Nature that confirms Oumuamua is the first known interstellar object in our solar system. Oumuamua is a cigar-shaped, 800-meter-long asteroid, red in color, with a surface similar to comets and organic rock asteroids found elsewhere in our solar system, according to the astronomers. Little is known about its composition, but its existence is, for now, exciting enough. Astronomers have long predicted this event could happen. Our solar system, in its adolescence, was a turbulent place. As the planets swirled into shape, some of the bigger ones jostled nearby material, sending some of it flying toward the edge of the solar system and beyond. Some of the rejected material could even make its way to another star. Since planet formation is quite uniform across the universe, astronomers believe Oumuamua is one of these outcasts tossed out of its home system. By this logic, there are likely pieces of our own solar system coasting somewhere in interstellar space or past another star. Oumuamua doesn't play by our rules. Astronomers only had about 2 weeks after the discovery to observe Oumuamua before it disappeared from the view of optical telescopes. Because the object is moving fast, and the light we get from it is reflected sunlight, the faster it moves away from both the sun and the earth, the faster it fades in brightness, said Karen Meach, an astronomer at the University of Hawaii Institute for Astronomy and the lead author of the paper. She and her colleagues condensed weeks and months of work into days and raced to apply for observation time at the world's most powerful telescopes, which is competitive and tightly scheduled. Observatories squeezed them in, and other colleagues donated time out of their own projects. Astronomers found that the properties of Oumuamua are unlike any of the approximately 750,000 asteroids or comets known to humanity. In our simulations, you can see that this could not have been from our solar system. It's simply going too fast, said David Farnacchia, a navigation engineer at NASA's Jet Propulsion Laboratory who was responsible for figuring out Oumuamua's trajectory. Its orbit was completely different too, Meach said. Scientists can figure out the shape of the orbit of objects that move around our sun, a measurement known as eccentricity. The eccentricity of all objects bound to the gravity of the sun falls between 0 and 1. The highest known eccentricity, 1.058, belongs to a comet that was discovered in 1980, but astronomers interpret this, along with other measurements that stray from the norm, as the result of objects getting jostled as they moved past giant planets like Jupiter. The eccentricity of the interstellar visitor is nearly 1.2. The difference looks small on paper, but it's big enough to confirm that Oumuamua doesn't play by our rules. Naming the space rock posed an interesting challenge. Comets are usually named after the discoverers, while asteroids are named only after their orbits have been accurately computed and established. The International Astronomical Union, the organization in charge of naming these objects, DIDNT, have guidelines for christening an interstellar rock in its designations. The IU uses the letter C for comet and A for asteroid, and this thing WASNTI, that not really. This object is only going by once, said Paul Choders, the manager of NASA's Center for Near-Earth Object Studies. The IU eventually came up with a new designation, I, for interstellar. Ground-based telescopes in Chile and Hawaii have already lost sight of Oumuamua. The Hubble and Spitzer Space Telescope are observing the rock this week, and may be able to track it until December. Oumuamua is now outside the orbit of Mars. It will pass the orbit of Jupiter next May, then Neptune in 2022, and Pluto in 2024. By 2025, it will coast beyond the outer edge of the Kuiper Belt, a field of icy and rocky objects. It will take many more years for the object to reach the Oort cloud, another region of floating objects, at the edge of the solar system. The arrival of Oumuamua had ignited the astronomical community, particularly asteroid researchers like Andy Rivkin, a planetary astronomer at Johns Hopkins University. Its departure feels just as abrupt. Rivkin put his own twist on an old refrain to describe how he felt about Oumuamua fading from view. "Don't be sad that it's over. Be happy that you saw it," he said. "Because it is really amazing that we saw it."